All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course and we're still doing our learning module. Let's have a look at what we went over tonight. Now, last night, if you recall, the last thing we went over was the holdout cross validation, and tonight we're going to pick up where we left off. So, one of the downsides of just this holdout cross validation is if we split something 50-50. We train using 50% of the data and test using the other 50%, is that there's a fair amount of data that we are now not using to train that we might be able to get a better model as a result. For example, one approach is known as the K-fold cross-validation. And what the K-fold cross-validation is splitting data into K sets and experimenting K times, using each set as a test set once and using the remaining data as training set. In the K-fold cross-validation, rather than just divide things into two sets and run one experiment, we divide things into K different sets. So maybe we divide things into 10 different sets and then run 10 different experiments. So if we split up our data into 10 different sets of data, then what we'll do is each time for each one of our experiments, we will hold out one of those sets of data where we'll say, let us train our model on these 9 sets and then test to see how well it predicts on the 10th set. So basically, what they're saying is for every 10 sets of data, we're going to hold one back, train 9, and then use the 9 that we train to test on the one that we held out. And then we pick another set of 9 sets to train on and then test it on the other one that we held out, where each time we train the model on everything minus the one set that we are holding out, and then test to see how well our model performs on the set that we did hold out, like I just said. And what we end up getting is 10 different results, 10 different answers for how accurately our model works. And oftentimes we could just take the average of those 10 to get an approximation for how well we think our model performs overall. That's basically what we did tonight. We actually did write some code here for a counterfeit note or counterfeit banknotes that I actually want to run, but I don't have the CSV that he has. It's a banknote CSV. I guess he got it from maybe the same database that we got our training for the call prediction models from. Like I said, this is the algorithms or the introduction to artificial intelligence, and that was on the TensorFlow. So I'm gonna go ahead and check the TensorFlow site that we got the call prediction stuff from and see if they have a banknote CSV. And if they do, that'd be awesome. So I could bring it over here and I could actually run this algorithm because I'm actually curious to see how it works and to see if we can implement it here. I don't want to just follow along and write the code out because, like I said, we did bring all of the inputs over that we're going to need and we wrote out the code perfectly. It looks pretty, but I can't do anything with it without that CSV. So what I'm going to do is I'm going to actually check in the morning, check the train or the TensorFlow site that we got the car prediction CSV from and see if they have a banknote CSV. And then I'm going to bring it over here. Then I'm going to attempt to run it. But yeah, that's as far as we got tonight. Like I said, we did take a lot of notes. I'm not going to go over everything because I do want to basically get that banknote CSV over here and see if I can get hands on with what he's saying so you can follow along more deeply. But of course, I'm going to keep you guys posted every step of the way. For now, this is the Python Papi. You guys stay Gucci.